Greetings to all the viewers. The session is going to cover with the heterocyclic compound called coumarin. Coumarin is the kind of a benzo-fused pyron. Its IUPAC nomenclature is provided for your kind reference. 2H-chromin-2-on is the preferred IUPAC name. Another alternative name is also provided. 2H1-benzopyran-2-on is the another method of pronunciation in accordance with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. IPAC nomenclature is provided for this benzo-fused pyran ring, where benzene ring and this pyran together existing. And here oxygen taken as a heteroatom. Here you can notice a ketonic functionality over the carbon number 2, and there is a conjugation within the ring system. And the session is powered by artificial intelligence, AI powered session it will be. And coumarin first extracted from the natural product which is called tonka beans. Tonka beans are said to be starting materials for the extraction of coumarin. Later on, so many other natural components also taken as the ingredients to extract this natural product coumarin, and many fold applications are also taken on the platform of laboratory research. Purview is also conducted, being it is a most widely applied compound. Here is the kind of natural extract coumarin you can clearly observe. Alkaline coumarin is also provided. So this is regarding the what topic chosen for the session, that is coumarin. In this session, the topics going to be discussed are intro regarding this coumarin compound and what could be the synthetic strategies in order to go for the laboratory viable pathways and industrial methodologies as well, and how many ways it able to exhibit its physical properties, general appearance and order, color. Everything will comes under these physical properties, and whenever it is going to react with the various chemical reagents, what could be the susceptibility for the chemical reactivity in order to transform the chemical skeleton of the compound, and eventually we will go for the potential applications in the various fields included with the pharmacological applications, material science applications, agrochemical applications as well. So many kind of potential applications are recorded for this compound, so that the session what we are conducting is most important in nature. Let me go with a brief intro regarding this coumarin compound. Coumarin is said to be a naturally occurring compound. It is said to be phytochemical, extracted from plant material, and in general, we can say it is the benzopyran ring. Benzopyran is a kind of used compound. It is said to be lactone. Whenever ester existing in the ring system, that is said to be lactone, so that it is the cyclic lactone system. Compound widely found in plants, so that we can say phytochemicals as well. It is known for its sweet and vanilla like aroma, right? So sweet flavoring agent it will be, and the vanilla flavor is also indicated by this coumarin compound. And being it is aroma characteristic odor containing compound, so that vital application in the field of perfumes and pharmaceutical applications, being it is the potential curative agent, so that pharmaceutical applications also characteristic for this kind of coumarin and its related hybrid scaffolds, precursor for many organic synthesis. So in order to synthesize some other heterocyclic compounds, some other accelerated compounds, here this coumarin may taken as a starting material. And three-dimensional representation of this coumarin is also provided, where you can notice the benzene ring, all the carbons bonded with these hydrogen atoms, and here is the another six-membered heterocyclic ring system, where oxygen is taken as one of the atom within the six-membered ring, and there is a double bonded oxygen in the form of ketonic functionality. This is the way three-dimensional representation is also provided for this coumarin molecules. Then being it is a natural product, so that what could be the richest sources, economic sources of this coumarin, let me explain. Natural occurrence is taken for this explanatory session. Coumarin is present in various plants such as tonka beans, being tonka beans from which Vogel is the scientist first extracted from these tonka beans in the 18th century, and cinnamon is another material which is used as a food spice, and lavender, from this lavender oil also we are able to extract this coumarin, being it is a kind of aroma containing compound. And the sweet clover is the another natural material where the richest amount of coumarin can be better extracted. And let me discuss regarding the significance of coumarin molecules. So many coumarin scaffolds are present. So many coumarin compounds are synthesized in the laboratory. Researchers are able to synthesize many folds of these coumarin scaffolds, many derivatives, auxiliaries, motifs are going to be synthesized in the laboratory, being it is most vital in the field of curative agents. That's a reason why few compounds are manifested, which are well-known marketed compounds, which already in the usage, right? Scopolatin is the kind of compound. Esqueletin is also present. You can clearly observe their chemical skeleton. Then hyperchromon is another compound you can clearly observe. Armillarizine A is a kind of another effective pharmacophore, and warfarin is the kind of drug which you can clearly observe. And penprocommon is a kind of another most important compound of the coumarin skeleton. Carbochromin, you can clearly observe it is the coumarin derivative. And novobiocin is the kind of antibiotic you can observe over here, and aflatoxin. Aflatoxin is a kind of agrochemical application containing drug of this coumarin molecule. This is the way multiple significant coumarin compounds are taken, which are already marketed drugs, right? So here is the coumarin that may be transformed into that novobiocin just now we gone through, which is effective antibacterial agent, where coumarin is the active pharmacophore over there, and it is connected by the amide linkage with another benzene ring. And here is another saturated pyran ring system is there, and ether linkage is provided over. And here you can notice the ester linkage with the terminal amino functionality. This is the way very extended organic chain is provided for you, which is said to be antibacterial agent that is derived from this coumarin core. And let me go with the another application of the coumarin in the field of medication. Anticoagulant agent. Anticoagulating agent is nothing but which is able to avoid the blood clots. So blood clotting tendency will be avoided, so that cardiovascular disease is better curated by this one. And this is a kind of a coumarin related drug where you can notice the hydroxyl functionality over the fourth carbon atom. And here is the side chain alkyl group with the benzene ring at the position number 3. This is the way anticoagulating coumarin disease curative is manifested. And here again another anticoagulative agent is provided, which is having a similar kind of representation. Only the difference is a kind of positional isomerism. Both are said to be almost similar, but only the difference is that benzene ring is present as such. And here is the CH2 C double bond with CH3, same identical molecules are provided. And here you can see anti-inflammatory coumarin. Anti-inflammatory is denoted as where injuries are present, where the swelling and muscle contraction, muscular pains, severe muscular pains are present. Those are said to be inflammations. Inflammations are better curated by the drug which is taken with the coumarin motif, which connected with this pyrazole ring, and that is in direct contact with this benzene ring. This is the way it is the multiple scaffolds containing a compound which is having amplified activity towards the anti-inflammatory property. So this is regarding the significance of the coumarin in the field of disease curation. And let me introduce another one is called ostol. Ostol is the kind of anti-IBD activity. It is exhibiting anti-IBD activity, which is said to be a kind of pesticidal function, especially in the field of agrochemicals. So that is a coumarin compound having methoxy at the benzene ring. And another lengthy alkyl chain is provided, which is in turn branched chain is located at this position. This is also the kind of effective pesticidal agent, especially in the field of agrochemical coumarin chemistry. Let me introduce this well-known, traded, marketed coumarin-related antibiotic compound just now we gone through, and it is the kind of coumarin nucleus. And here is the amide linkage benzene, and benzene is having side chain alkyl with olefinic functionality, and hydroxyl functional group is also present on this benzene ring, and this coumarin is linked with the ether linkage is there in between this coumarin and this pyran ring once again, and here is the kind of ester linkage is located, which is said to be novobiosine. Novobiosine is the most effective antibiotic, having the effective curation against the bacterial infections, and even you can incorporate the chloro functionality over this benzene ring of coumarin, so that intensified activity towards that disease curation is possible in terms of antimicrobial activity. That is said to be chlorobiocin. Chlorobiocin is also the kind of similar auxiliary like novobiocin. Only the difference you can observe here will be a kind of inclusion of chlorofunctionality over there. Chlorofunctionality will intensify the antibiotic activity of this coumarin drug, right? So this is the way antibiotic traded coumarin compounds are provided. So by this, we concluded with the significant approach towards the coumarin, so that being it is highly valuable synthon, valuable motif in the field of medication. That's the reason why. Let me look into its a synthetic strategy regarding the coumarin formation in the laboratory viable methods and industrial possible ways as well. So many scientists worked up on this coumarin synthesis, being it is very pivotal and potential compound. Perkin started with the coumarin synthesis, and Pechman synthesis also observed, and the Claisen synthesis will be there. Kostanecki Robinson annulation will be there, and Neuen-Ogle condensation is the most familiar one, and most of the scientists will go through this one. Reformarsky reaction is also possible for this coumarin synthesis. Wittig olefination is more familiar, but Wittig also tried for the synthesis of coumarin as well. Michael addition reactions also giving rise to coumarin as the final product. Heck, lactonization reaction is also giving rise to coumarin as the final motif, and Baylis-Hillman synthesis is also leading to the formation of this coumarin as the final product. These many scientists, their valuable efforts are giving rise to coumarin as the final product. In this regard, we are going to discuss about few important named reactions pertaining to coumarin synthesis on laboratory viable methodology. Perkin reaction is most important and most initial method of the synthesis for this coumarin. In the early 1968, first time Perkin demonstrated the manufacturing of, being it is the natural product, so many natural ingredients are there, natural spices, plants. We are able to directly extract the coumarin, but in parallel method, it is also possible to synthesize the coumarin in the laboratory viable ways. The first effort was successfully carried by the eminent scientist called Perkin in the year 1968 for the construction of coumarin moiety. He gave the synthesis by condensing this salicylaldehyde in the presence of acetic anhydride. Salicylaldehyde condensation is carried with this acetic anhydride in the presence of sodium acetate catalyst. This is the way Perkin reaction is possible. Salicylaldehyde is supposed to be treated with acetic anhydride. They are going to react in the presence of basic condition, and the reaction is giving rise to alpha beta unsaturated aromatic acid. So that sodium acetate followed by the molecular cyclization to be carried, giving rise to coumarin as the final product, right? Salicylaldehyde, acetic anhydride, sodium acetate under basic conditions, giving rise to coumarin as the product. This entire process is said to be what? Perkin reaction for the coumarin synthesis. In order to achieve this reaction, let me go with the detailed mechanism for this Perkin reaction. Acetic anhydride initially, being it is an active methylene group containing species in the presence of sodium acetate. Acetate is a stronger base in order to pull up this H positive, giving rise to carbene. Carbene better resonance stabilized with this adjacent carbonylic functionality, and that carbene generated is able to bind with its aldehyde by the process aldol condensation, so that this carbene is binding over this aldehydic functionality, so that new carbon-carbon bond originated, which is acetyl, which is participating in the acetyl group transfer from the oxygen to this another oxygen atom. So that here OAC is generated. OAC stands for what? Acetyl group. From this oxygen, it is shifted to another oxygen atom. This is acyl group transformation, acyl group transfer reaction, right? So the terminal oxide is originated. The terminal oxide is more stabilized because of quasi resonance between the two oxygen atoms at the terminal carboxylate carbon, right? Quasi resonance stabilized it will be. That's the reason why immediately this acetyl will be transformed to this oxygen atom. Later generated oxide will proceed for this nucleophilic addition over this carbonylic carbon atom of another acetic anhydride molecule, that able to form acetyl group over this oxygen. So again, O acylation is accomplished, giving rise to acetic acid as the byproduct. Acetic acid is leaving over there because acetate group is disappeared from the side. uh, in the next step, what we are going to do, here we are having active methylene group because OAC is the kind of functionality in the adjacent carbon atom, and here we have acetate functionality again, OAC functionality again, so that the carbon whichever present in between is experiencing high active methylene carbon, and the hydrogens whichever presents are very loosely bonded, and the ease for the generation of carbon ion is very familiar with this carbon atom, being it is acidic. Carbon acidic hydrogens will be loosely bonded and readily replaced under a basic condition, so that H positive will be removed, giving rise to carbon. That carbon will form a double bond in between immediately. OAC acetate moiety will be departed from the adjacent carbon atom. Subsequently, there is a olefin, there is a carbon-carbon double bond formation is possible by the removal of acetic acid as a byproduct. Acetic acid is departed as a byproduct, so that we will experience carbon-carbon double bond formation. Later again, one more acetate ion is able to react over this carbonylic carbon atom. Subsequently, this bonded electrons are departing towards this oxygen, so that here this acetyl moiety is eliminated. Acetyl moiety is completely eliminated over there. So we are experiencing again C double bond O minus. That is protonated, further protonated, giving rise to alpha beta unsaturated carboxylic acid. Alpha beta unsaturated carboxylic acid will be originated. This able to protonate further under acidified conditions, giving rise to oxonium ion. This oxonium ion is a better leaving group from the system, so that immediately wherever oxygen is there on this benzene ring is accommodated by the lone pair of electrons. These lone pair of electrons are taking part of this ring cyclization over this carbonylic carbon atom. Whenever these electrons are participating in the bond formation, simultaneous bond departure of the water will take place, and water is eliminated as a byproduct. Subsequently, you are able to achieve coumarin as the final product, so that already double bond existing in between the carbon atoms, and here is the ketonic functionality that may not be disturbed, and here oxygen whichever forming a bond is immediately go for the deprotonation at this oxygen, so that here alkyl substituted coumarin is generated by these many steps of reactions. So here the important starting materials taken are, one is acetic anhydride, another is sodium acetate for the initiation of the reaction, and another reactant is required, that is salicylaldehyde. So these many reactants are finally giving rise to coumarin as the final product by Perkin reaction. Let me introduce another named reaction for the synthesis of coumarin called Pachman condensation process. Pachman condensation process requires phenols and beta ketoesters. These two reactants are mixing together, and the required nature of the reaction condition will be acidified conditions are required, and widely used for the manufacturing of various coumarin derivatives are possible. Pachman condensation is initiated by the eminent scientist called Pachman in the year 1883. Typically, carbolic acid is one of the starting material and react with the carboxylic ester. Ester can be taken, and this carbolic acid to be treated. That carbolic acid stands for phenol again. So here beta ketoester is another starting material to be treated under acidified conditions. We mentioned acid conditions are required so that Lewis acid AlCl3 aluminum trichloride is added, so that phenol able to react with this beta keto ester, giving rise to 4-methyl coumarin as a final product. So alkyl group might be methyl, ethyl, any kind of alkyl it may be. That depends upon your requirement. In order to achieve this reaction, we have plausible mechanism. Initially, this beta ketoester is said to be active methylene compound to be reacted in the presence of AlCl3. AlCl3 is a Lewis acid, right? So Lewis acid having natural tendency to bind with the electron-rich centers. So that electron-rich centers are two oxygens only because they are accommodated with the lone pair of electrons, right? So they are able to bind with this AlCl3 so that there is existing a chelation among. So chelating ring formation is occurred. Whenever chelating ring is joined over there, this carbon atom is participating in a nucleophilic addition with this phenolic moiety. Phenol is operated over there. So subsequently, alkoxy group will be departed. Alkoxy group will be departed, giving rise to oxygen. Oxygen is this oxygen is going to bind the oxygen whichever binding here. That oxygen is having which group? Benzene ring. That oxygen is having the benzene ring, and the another moiety will be this carbonylic linkage which remains as such, and adjacent CH2 is there. CH2 remains as such. Here we have C double bond O, C double bond O. That C double bond O is in contact with AlCl3, right? So that here it is mentioned as AlCl3. And this carbonylic linkage again having methyl. So here what the process takes place, the nucleophilic addition of this phenolic oxygen is taken over this carbonylic ester. Whenever this lone pair of electrons are participating in the bond formation, simultaneous departure of this alkoxide in addition to the H positive is possible, so that ROH will be removed. That is said to be alcohol. Whenever alcohol is removed, here the formation of ether linkage. So here O will remains on this carbon atom. Whenever this oxygen is binding at this carbon atom, this carbonylic linkage is present at the adjacent site, and the AlCl3 totally moving towards another carbonylic linkage only, which is free now, right? So this is the way a kind of ester linkage is originated. New ester linkage will be originated. Now the task is about to cyclization process. In order to cyclize this intermediate compound, the benzenoid ring will be disturbed, and the benzene pi bond is participating in the ring cyclization, and simultaneous ketonic group will be delocalized towards the oxygen atom. Whenever this bond is shifting, what it will do? Lone pair of electrons on the oxygen atom will take the double bond formation, so that oxonium ion will be generated, and here we got OAlCl3 at this carbon atom, and again already we have this methyl over there, so that here one oxygen containing AlCl3, one methyl group are located over there. Benzenoid nucleus totally disturbed. So now it is unfavorable, right? So immediately it go for that correction. How the correction is carried, retention of benzenoid is very necessary in order to satisfy the aromaticity. That's the reason why the bridgehead carbon is losing the proton, so that bonded electrons are back polarizing in order to form a pi bond in between. So here the pi bond is back polarized towards the oxygen in order to give the lone pair of electrons to compensate the positive charge. So that here benzenoid nucleus is retained, and oxygen is becoming uncharged. So next step, what we are supposed to do, the OAlCl3 will be very bulky in nature and more easily departed, being it is better leaving group. So that in addition to the bonded electron, oxygen is departing as a O minus. Oxide will be removed from this side, so that here the carbocation will be originated. Carbon cation to be satisfied by adjacent proton. Whenever proton is losing, what happens? Bonded electrons taking part of pi bond formation, so that here the new pi bond is originated and existing methyl remains on the carbon number 4, and here O minus, whichever removed, get a bind with this H positive, giving rise to OH. So OHAlCl3 will be the byproduct, and ultimately we got 4-methyl coumarin as the final product by means of Pachman condensation. The reactants for Pachman condensation are, one is phenol, another is said to be what? Beta keto ester. Reaction is initiated or facilitated by Lewis acid AlCl3, and the expected product will be 4-methyl coumarin as the product. So this is the way reaction mechanism is also manifested. And let me introduce another named reaction for the coumarin synthesis under laboratory scale, which is a Claisen rearrangement. Preparation of 3,4 substituted coumarin utilizing trifluoroacetic acid. Trifluoroacetic acid is a strong acid in comparison to the acetic acid as a homologous promoter via Claisen rearrangement reaction. Homogeneous promoter it will be. Homogeneous promoter stands for whatever the phase is there already existing, the same phase reaction is accomplished. All the reactants are taking on the same phase, which is said to be homogeneous reaction condition. And the Claisen reaction is operated in order to achieve this kind of coumarin by reacting phenol with the allyl alcohol in the presence of basic condition. Sigma-tropic Claisen rearrangement is taking part of this reaction in the presence of trifluoroacetic acid and giving rise to coumarin as the final product. Let me show how the reaction is accomplished. Here phenol is one of the starting material. Here is the kind of another starting material taken. That starting material, one is phenol, another is the protected allyl alcohol. This is called allyl alcohol. Protected allyl alcohol means so actually double bond adjacent carbon atom if having OH, that is called allyl alcohol. If OH is protected by acetyl, that is O-acetyl allyl alcohol will be there. This is said to be protected allyl alcohol, and we require the strong base like sodium hydride. Another most important reagent is trifluoroacetic acid is the facilitator for the reaction. Reaction is quenched to minus 40 degrees in order to go for the low temperature operation, and giving rise to product multi-substituted, multi-alkylated coumarin is generated as the final product. In order to achieve this reaction, initially the reaction is accomplished between the phenol and this allylic alcohol. So here oxygen containing lone pair of electrons will initiate the reaction with this double bonded carbon. Double bond is back polarized towards the another carbon-carbon bond, so that here olefinic bond will be originated, and OAC. O-acetyl is a better leaving group being it is bulkier, so that we are supposed to remove this O-acetyl from this carbon, from alpha carbon atom, so that here the double bond will be originated. Double bond will be originated. Here you can locate oxygen to carbon bond formation. Oxygen to carbon bond formation is possible. After getting this oxygen to carbon bond formation, here the double bond is there, and that double bond is accompanied by the ester linkage over there. Now the process is 3,3 sigma tropic rearrangement. 3,3 sigma tropic rearrangement stands for, let me count 3 atoms of one side, 3 atoms of another side. 1, 2, 3, 4, 5, 6. Here 3 atoms will participate in one kind of bond fusion, and another 3 atoms will participate in another kind of bond fusion, which is accompanied by 3,3 sigma tropic rearrangement. Let me explain in detail. This is taken as the first carbon. So first carbon is departing the pi bonded electrons towards this oxygen, and immediately oxygen carbon bond will be cleaved and giving back towards the 4th and 5th pi bond formation. And wherever already existing pi bond is there, that is moving in between this 1st and 6th carbon atoms. So existing 3rd, 4th bond will be broken, and 5th, 6th, 6th to 1st bond will be formed. This is the way 3,3 sigma tropic rearrangement giving rise to a new kind of auxiliary, new kind of intermediate formed, where you're experiencing here ketonic functionality. Here we are having here we are having olefinic double bond. This is newly formed double bond, and between this third and fourth the bond already broken, that is not considered. So here the olefinic double bond generated in between, and already existing ester functionality which remains as such. COOR is remaining as such, and the sixth carbon is having alkyl side chain. Alkyl side chain remain. Among the first and sixth carbon, new bond existing, new bond formation is noticed. This is the way new bond is located in between first and sixth carbon atoms. This is the way compound will be reshuffled by means of 3,3 sigmatropic rearrangement process. Later, this oxygen molecule whichever present will be polarized, and whenever this ketone is polarizing, immediately bridgehead carbon is losing H positive, and that able to retain the benzenoid nucleus. Whenever benzenoid nucleus is retained, here H proton released will bind with this O minus, giving rise to hydroxide at this position. Whatever hydroxide generated, that again is becoming like a active functionality to participate in the ring cyclization process once again. So that lone pair of electrons in the oxygen are responsible for the new bond formation between the oxygen to carbon atoms of carbonylic carbon. So that there will be existence of a cyclized oxygen to carbon bond formation. And here the whenever this bond is forming, substantially the adjacent alkoxy group will be removed. The alkoxy will be removed, then only here the bond formation with this carbon is possible. So ketone is retained. Ketone is retained at this position, position number 2. Here we have a olefinic double bond, right? Wherever olefinic double bond is there, that olefinic double bond again participating in the delocalization. Bond will be moving towards the carbon atom, and adjacent hydrogen will be removed, and this bonded electrons are taking part of the pi bond formation. Wherever pi bond is polarized toward the carbon atom, that is experiencing negative charge, right? This negative charge will take up this H positive, giving rise to CH3 finally. This is the way. This is the way final product will be the poly-substituted coumarin. So where third position with methyl, fourth position with alkyl, and upon the benzene, somewhere alkyl group is located. This is the way phenol is supposed to be reacted with this allylic alcohol in the presence of strong base sodium hydride and trifluoroacetic acid as a catalytic medium, and reaction conditions initially required at -40, and at this final stage we are supposed to raise the temperature slightly in order to achieve this expected substituted coumarin product by means of Claisen condensation process. Why it is said to be Claisen condensation? In accordance with the pericyclic reaction, it is participating in the 3,3 sigmatropic rearrangement, right? 3,3 Claisen rearrangement is taking part of this one, right? So that it is said to be what? Claisen rearrangement process. The most familiar kind of coumarin synthesis will be Neue-Weinkel condensation. Many coumarin derivatives have been derived successfully by suitable starting materials by Neue-Weinkel condensation process. 3 substituted coumarin derivatives can be synthesized by means of this base mediated process, right? The reaction must be carried out in the presence of 2-hydroxybenzaldehyde coupling partner containing the active methylene group in a presence of bees under heating conditions. The yield obtained from this coumarin product is acceptable range. The possible mechanism is also provided. Here is the salicylaldehyde. How the Perkin condensation is carried in the same manner. Again, we are starting with this salicylaldehyde as a starting material. Here taken with the ester. So salicylaldehyde to be condensed with ester under basic conditions, and heating is required, and a certain time is required to accomplish the reaction, and giving rise to substituted alkylated coumarin as the final product, right? So in order to achieve this reaction, initially we are taking dimethyl malonic ester. dimethyl malonic ester was taken here, and that is supposed to be treated with piperidine. Piperidine will be a base, right? So that being it is the active methylene compound more susceptible to release the H positive, giving rise to carbene ion. This is the most flexible material to originate the carbene, being the carbon is in conjunction with the two electron withdrawing substitutions over the adjacent nearby positions, so that piperidine is able to originate the carbene intermediate from this kind of active methylene compound, and that able to react with salicylaldehyde at aldehydic functionality. Whenever carbene is supposed to be reacted at a carbonylic aldehydic functionality, so immediately pi bond is moving towards oxygen. There will be a new bond origination between the carbon and carbon, so that in conjunction to this benzene ring, this O is taking up the proton, so that immediately becoming OH, and this carbon is binding with another carbon where we are having already COO-Me over one carbon atom. Another COO-Me is also present. This is the way the molecule generated will dehydrated. So immediately OH minus and H positive removed from the adjacent carbon atoms, giving rise to olefinic double bond. The double bond whichever originated over there will participate in the ring cyclization with the adjacent hydroxyl, right? So here we are having hydroxyl, here we are having ester functionality. Ester functionality having greater provision for the ring cyclization. Whenever the lone pair of electrons of hydroxyl are taking the bond formation with this carbonylic, methoxy will be subsequently departed. Whenever methoxy group is departed, you are supposed to experience the six-membered ring system with the cyclic lactone ring. And here is the ester linkage over the position number 3. The position number 3 ester linkage, whichever present, you simply assume it as a alkyl group as well. If you want to remove this, very simple, water to be added so that it will be hydrolyzed, giving the it's to carboxylic acid. Slightly rising the temperature, it will be decarboxylated, so that here unsubstituted coumarin is also generated. But in general, you are achieving this alkyl substituted at the position number 3. And moreover, another somewhere alkyl group is also located on the benzenoid ring that may not be specified. It is not specific, rather somewhere it is located. So this is the way coumarin with the substitution is provided as the final product by means of Neue-Venegal condensation. In order to achieve this reaction, one to be the salicylaldehyde, another to be the ester. So in specific, I'm taking this kind of active methylene compound so that the product is expected to be the substituted coumarin. Series of mechanism is also provided. Reformatsky reaction is another named reaction. Always Reformatsky reaction is applying a zinc catalyst. This is the most obvious catalyst which is linked with the scientist, right? The scientist is most familiar with the zinc catalyst. Reformatsky reaction is also most familiar in the organic synthesis as well. And being it is heterocyclic, here also it will be operated. Again, we are taking with this kind of alpha hydroxyketonic salicylaldehyde derivative only. Again, you may take salicylaldehyde again, and here it is taken as a kind of ethyl acetoacetate active methylene compound to be taken, and the sodium carboxylate is the kind of salt added over, and suitable solvent and optimum temperature to be applied in order to achieve the coumarin as the final product. In order to operate this reaction, this sodium carboxylate to be reacted upon this salicylaldehyde molecule, which to be deprotonated. Deprotonation being it is the carboxylate is accepting this H positive, and there is a alkoxide formation. So here the formation of alkoxide phenoxide in specific. So that oxide is having stronger tendency to bind with this carbonylic carbon atom of this anhydride type of compound. Here you located anhydride type of compound, right? This anhydride is supposed to be reacted with oxide over the carbonylic carbon atom, and whatever adjacent oxygen will be there, that is taking the bonded electrons and is departed. Whenever the entire part is departed, here the origination of ester linkage. How the ester? Let me show. O minus is binding over this carbonylic carbon, so that here carbonylic carbon is there and adjacent CH2 is there, and here we have R group. The entire ester group is located over the position number 1. And now base is operated. Base is required in order to achieve this carbene ion. Being it is the active methylene carbon, what it will do? Immediately loses H positive towards the base, giving rise to carbene intermediate. Carbene intermediate is most required for ring cyclization reaction. At the carbonylic carbon atom it able to cyclize. Whenever the cyclization is accomplished, new carbon-carbon bond will be originated. And subsequently acid catalyst is operated, so that O minus immediately protonated, giving rise to hydroxyl functionality over the position 4. Subsequent removal of water is required from the two adjacent positions of 3rd and 4th, so that there will be a new origination of olefinic double bond, and that restoring that coumarin nucleus and giving rise to coumarin as the product. This is a very Formatsky reaction will be operated by taking salicylaldehyde and in a hydrate type of compound. Condensation it is regarded to be and giving rise to a cyclic lactone product called coumarin. And another most familiar reaction called Wittig. Wittig reaction is most advantageous in the field of olefin synthesis. Wittig olefination is most familiar for the organic scientist, organic persons. Wittig reactions of aldehydes and ketones mixed with the Wittig phosphine reagent triphenyl phosphonium ylide. Trifonium phosphonium ylide is the characteristic for the Wittig olefination. Here also we are applying the same reagent in order to originate this coumarin as the product. So in order to achieve this one, German chemist George Wittig, he operated and succeeded this synthesis of this coumarin by using this triphenyl phosphonium ylide characteristic reagent. So he is accorded with the Nobel Prize in the chemistry for the year 1979 for the discovery of significant olefin synthesis. He is most familiar for the Wittig olefination process only, but he also extended his research for coumarin synthesis as well, right? So let me show. Again, I'm taking salicylaldehyde. Salicylaldehyde to be treated with this Wittig olefinating agent. This is said to be what? Triphenyl phosphinium ylide. Triphenyl. So 3 phenyl rings are there on the phosphine. Triphenyl phosphinylide is the kind of key reagent which is operated upon this salicylaldehyde, giving rise to substituted coumarin in addition to the triphenyl phosphone as the byproduct. In order to achieve this reaction, let me go for the initial formation of this ylide. In order to form the ylide, one of the material required is alpha bromo ester. Alpha bromo ester to be treated with triphenyl phosphine in the solvent ether, which is non-polar in nature. That's the reason why the reaction is accomplished in between. Bromo will be replaced with this triphenyl phosphine, triphenyl phosphinium. Intermediate will be originated. Base is operated over there. Whenever base catalyst is operated, there will be a kind of double bond formation is possible. Hydrogen will be base able to remove the hydrogen from this adjacent carbon atom, being it is active methylene, so that H positive removed, and there will be the origination of the olefin double bond, which is called a ylide. This is called a ylide. Whatever we are using here, phosphinium ylide, that phosphinium ylide is taken as a key reagent that operated upon this salicylaldehyde. Salicylaldehyde is having this carbonylic or aldehydic center is there, that is reacted with this compound, so that there is a existence of 4-membered ring system. 4-membered ring system will be generated. How the 4-membered ring system? In between the phosphorus and oxygen, there will be a new bond formation due to this pi electrons are moving towards the ring cyclization. Whenever electrons lost, this carbon will accept the pi electrons from the adjacent carbonylic carbon, giving rise to again here carbon-carbon bond formation. So that there is a kind of 4-membered ring system. The 4-member ring system whichever generated is called oxaphosphatane. This intermediate whichever generated is called oxaphosphatane. Oxaphosphatane generated is not much stable, rather it is highly sterically hindered one. Immediately go for ring departure, ring opening reaction is most familiar for this one, so that the phosphorus carbon bond whichever present will be broken, and bonded electrons taking part of this phosphorus oxygen pi bond formation, and whichever carbon oxygen bond is there, that is back polarized to get this olefinic double bond among this carbon and carbon atom. So here the byproduct what we are getting, triphenyl phosphone, that will be departed simply, and here we got olefinic double bond. Now the ring cyclization is the step number 2. How the ring cyclization is accomplished? OH is operated over there. OH is driving towards this ring cyclization, and lone pair of electrons are making the bond between this oxygen to carbonylic carbon atom. Immediately alkoxide will be removed. Whenever alkoxide is removed, and simultaneous H positive removal from the hydroxyl is possible, so that here alcohol will be the expected byproduct. Whenever alcohol is removed, oxygen to carbon bond is allocated, and that giving rise to coumarin as the final product. This is the way Wittig is also got success in the synthesis of coumarin, so that the valuable various chemical components got synthesized by this eminent scientist. So he is accorded with the Nobel Prize in the year 1979. Now, another synthetic methodology is also provided. If you observe the various synthetic strategies, most of the starting material taken from the salicylaldehyde only. Again, we are taking salicylaldehyde as one of the starting material. Alpha ketoester is the another material taken, so that we are supposed to condense between the salicylaldehyde and alpha ketoester in the presence of magnesium peroxide. Nano ultrasound sonicated method is applied. It is the kind of green methodology. It is the kind of state of art technology in order to achieve the compounds by means of green methodology protocols, right? So these two compounds are supposed to be condensed in such a manner, giving rise to coumarin as the final product. The important thing to be observed is ultrasonication is the step taken, and moreover all the reactants got mixed up under solvent free conditions without any solvent media. The reaction is accomplished in order to achieve the product with the high yield. This is the way green methodology is adopted for the synthetic strategy of the coumarin. And another green methodology is the microwave irradiation. Microwave assisted coumarin synthesis is accomplished between the phenol and a kind of beta ketoester. This is said to be beta ketoester. The reaction exactly resembling with the Pachman condensation. FeCl3 is said to be a kind of catalyst, that is the Lewis acid applied over that able to giving rise to coumarin as the final product. Now the reactants are supposed to be irradiated by the microwave radiation, so that the final product achieved within few minutes only, right? So this is the way coumarin manufacturing is possible by green protocols. Let me go for the solvent-free non-noble condensation between the salicylaldehyde and beta ketoester. So salicylaldehyde is supposed to be treated with the beta ketoester in the presence of piperidine solvent. The most important point to be remembered in the synthetic strategy of the coumarin is all the reagent must be taken under mild operations only. Extreme drastic conditions, vigorous conditions, and fuming conditions, concentrated conditions may not generate this kind of coumarin ring. Being coumarin ring is made by the lactone, immediately ring opening is the consequence. Whenever we are operating with the drastic condition, rather we can go for the mild conditions like piperidine. Any mild reagent is required to accomplish the synthesis of the coumarin. This is the way solvent free reaction is accomplished in between salicylaldehyde and beta ketoester by the process Knoop-Vinagel condensation. And moreover, the solvent may not be applied, rather we are applying only base, and room temperature is sufficient. Within 5 minutes the product is accorded in the high yield with high quality as well. If you observe the yield of the product, that is extremely larger, 99%, almost higher quality product is accorded by the solvent free Knoop-Vinagel condensation process. Synthesis of sulfonyl coumarin is also possible. Sulfonyl coumarins are more potential in the field of antimicrobial strategy, antimicrobial application purview. So that let me go for the synthesis by combining one of the starting material is the kind of phenyl ester and having a triple bonded compound over there, and I'm taking saturated pyrrole called pyrrolidine where sulfuryl moiety is present and there is another characteristic carboxylic acid moiety is there over the position number 2. Silver nitrate is treated as a catalyst over there, and K2S2O8 is another reagent which applied over that able to go for the ring cyclization. Within the molecule only we have the sufficient intermolecular cyclization is the characteristic reaction to be performed. Already we are having lactone, certain extent of lactone ring strategy. Here oxygen is there, here C double bond is there, may not be disturbed. Rather, wherever triple bond is there, this triple bond will go for the ring cyclization reaction, and subsequently the carbon whichever participating in the ring cyclization will experience this sulfonation, so that third position is accomplished with the sulfonation, and moreover, we are having this phenyl linkage over the position number 4 that may not be disturbed. Only the thing to be noticed is the cyclization between the carbon and benzene carbon atom. This activation is accomplished by means of this silver nitrate and K2S2O8 and acetonitrile taken as a solvent, and water. Acetonitrile water solvent mixture was taken in the 2:1 ratio. Water mediated reaction it might be, so that again we can designate the reaction as a green methodology. Aqueous mediated synthetic methodology is more prominent, more significant in general, giving rise to coumarin as the final product. By means of this, we successfully accomplished the various methodologies. So many scientists efficiently prepared the coumarin in the laboratory scale, being it is very vital in the application purview. That's the reason why various methods, detailed description included with their mechanism were deliberated in the earlier discussion. Now we are going to enter into the physical properties of the coumarin. Physical properties are said to be molecular formula C9H6O2, right? 9 carbons, 6 hydrogens, and 2 oxygen taken part of this skeleton of the coumarin. Appears like a colorless or white crystalline solid. It is the kind of solid substance and having sweet vanilla-like scent, perfumery odor will be there. It is the kind of vanilla odor existing molecule, and the sweet smell is also given for this compound. And melting point, it melts at the temperature of 68 to 78 degrees centigrade. Probably it will be a kind of solid in nature, and moreover crystalline substance, crystalline having highly regular three-dimensional representation of arrangement of molecules, so that we are able to crystallize the compound as well, and boils at the temperature of 291 degrees centigrade, so that higher temperature around 300 degrees centigrade is required to boil the coumarin molecule, and the density is somewhat less than the water. 0.935 gram per centimeter cube is the density of the compound, so that whenever it is added to water, it will float on that, being it is lighter in weight. Molecular weight is weighed as 146.14 gram per mole, slightly soluble in water because the maximum content is organic in nature and the polarity is extremely negligible. That's the reason why there will be the complication. The most complication with this coumarin will be a solubility pattern only. The solubility of the compound is very negligible in water, and moreover, organic solvents are more suitable in order to dissolve this one. Ethanol, acetone are most suitable compounds, acetonitrile as well, benzene and chloroform. Refractive index, whenever it is moving from one medium to another medium, that angle whichever generated in between two different mediums of that will be 1.5. That is said to be its refractive index, and UV absorption is a characteristic at the range of 275 to 310 nanometers. And being it is a fluorescent in nature, exhibiting fluorescent UV light is possible. This is the most prominent application for this coumarin molecule, right? Here is the description, whatever we gone through, that is clearly explained over here. Here is the Coumarin nucleus provided where benzenoid nucleus is there. Here is the pyran ring you can locate, and adjacent C double bond group is there. This is said to be a kind of ester existing in a cyclic nature called a lactone. And here it is composed by 9 carbon atoms, 6 hydrogens and 2 oxygens respectively. And three-dimensional representation is also provided where all the atoms are mentioned with the ball and stick model, and there is a heteroatom oxygen mentioned with the blue lobe, and the carbons are manifested with the red color lobes. Ash color lobes indicated for the hydrogen atom. This is the way a Coumarin molecular representation is provided in three-dimensional platform. And it is existing in a white color crystalline solid, so that the white color crystalline solid is also provided for understanding this. Organic solvents are given because organic solvents are more suitable to dissolve this compound. So water solubility is almost negligible, being it is non-polar in nature, and most of the carbon content is dominating for this solubility in non-polar solvents. And here the characteristic property of the compound will be the fluorescence. It able to re-emit the UV light, so that fluorescence is the characteristic nature for these Coumarin compounds. By that physical properties section was completed, let me discuss regarding the chemical properties of the coumarin. Aromaticity of the coumarin compound. Coumarin is a better aromatic in nature, and it is the class of benzopyran molecule, and in accordance with the IUPAC chromatone is the kind of name accorded. And it is exactly following the Huckel rule. Huckel rule is said to be 4n+2 pi electron system should be present within the molecule. Whenever n value is taken as integers like 0, 1, 2, then we can satisfy that Huckel aromaticity. And it is the cyclic conjugated system. There will be a conjugation among the pi bonds. Obviously, benzene is the conjugated system, and planarity is accorded for the molecule because of the sp2 hybridization. The entire molecule is said to be flat in nature because of sp2 hybridization. All patterns are confirming that coumarin is aromatic in nature and perfectly obeying the Huckel rule. And in continuation to the aromaticity, it is the class of benzopyran. Benzene ring fused with the lactone will be there. Lactone ring contains the conjugated system. Double bonds are present, and oxygen lone pair are taking part of this electron delocalization or gain. The electrons are contributed by the oxygen inside the ring system in order to make the conjugation within the ring system. And the pi electron delocalization across the two rings are possible, and delocalization is the important characteristic for that one, and planarity is another characteristic for the aromaticity. Cyclic system is also provided over there, and 4n+2 is equal to, if you count the number of electrons within the molecule, here obviously benzene is contributing 6 pi electrons, and whenever 6 pi electrons by the benzene ring, 7, 8 will be there from the carbon atoms, and oxygen contributing 2 electrons, totally 10 pi electron system it will be. So 10 pi electrons are taken whenever you are substituting 10 pi electrons, so that n value is calculated as 2, being it is an integer, so that obeying the Huckel rule, and indeed aromaticity is satisfied. Now, another question arises, why coumarin is said to be weakly acidic in nature? What could be the reason behind this one? Pure acidity is accorded for the compound. That is because of the pyran ring. Pyran is having electronegative oxygen that immediately react with the sodium hydroxide under aqueous conditions. So, aquated sodium hydroxide, whenever treated over, being it is a kind of strong base, so that immediately ring opening reaction will be the consequence, and giving rise to carboxylic acid upon opening of this ester linkage. Ring opening of the ester linkage giving rise to this carboxylic acid, right? So whenever the same coumarin is supposed to be reacted with sodium hydroxide at extremely elevated temperature, obviously this ring opening is the consequence giving rise to the starting material, whichever we started with, that is salicylaldehyde, and instead we are achieving this salicylic acid. Sodium salicylate is the one of the product, and sodium acetate is another byproduct is accorded. This is the way the reaction towards the sodium hydroxide indicating that there is acidity. Being it is the ester, it is the derivative of carboxylic acid, so that obviously you can assume the compound is slightly acidic in nature, and obviously go for the reaction with the bases giving rise to ring opening, and corresponding carboxylic acids will be originated. And let me perform the reduction over this coumarin. Coumarin is supposed to be reacted with hydrogen under catalytic condition. Let me operate with this Raney nickel. Initially, one of the pi bond in the pyran will be go for reduction process. Being a benzene ring is somewhat inert comparatively compared to this heteroaromatic ring. Benzenoid nucleus is more stable. Obviously, that's the reason why initial reduction giving rise to the saturation ring of the heterocyclic without disturbing the benzene ring. Later, it may proceed for the complete reduction by improvising the hydrogenation process so that entire ring system will be saturated so that saturated coumarin will be originated. Later, that oxygen containing ketonic nucleus will be slowly departed from the system, giving rise to only oxygenated bicyclic ring system by leaving this ketone. And another possibility is also exist in between the ester linkage. There will be the ring opening reaction giving rise to two alcohols. This is another possibility. These many products will be achieved whenever hydrogen in the presence of Raney nickel is operated over this coumarin, so that mixture of multiple reduced products will be generated. Let me go for the halogenation of the coumarin. Halogenation of the coumarin is possible upon this heterocyclic ring rather than the benzene ring, so that able to generate that 3,4 dibromo coumarin as one of the product, or else there will be a 3 bromo. 3 bromo coumarin is also possible, and 3 comma 4 5 3 comma 6 dibromo coumarin is another product. There instead of the one product, we are able to achieve the multiple products. Being halogens are more reactive towards this kind of electrophilic substitution, giving rise to multiple products as a mixture of products. Whenever coumarin is supposed to be reacted with the chlorinating agent, that is chlorine, directly giving rise to 3-chlorocoumarin. So generally, the position number 3 is more susceptible for this kind of electrophilic substitution reaction because of the high electron density. Now, reaction with Fenton's reagent. Fenton's reagent is designated as the mixture of ferrous sulfate and hydrogen peroxide. Whenever ferrous sulfate and hydrogen peroxide are treated together, the table to generate hydroxyl functionality, second, third, fourth, fifth, sixth, seventh carbon atom. So that 7 hydroxy coumarin will be the expected product by means of Fenton's oxidation. This is said to be hydroxylation. Hydroxyl moiety is incorporated over the position number 7. So the compound whichever generated is the significant one, which is called amblyferone. It is the traded one. This is the established compound with most familiar and applicable compound regarding this coumarin, that is said to be amblyferone, which is synthesized by this reaction of Fenton's reagent over this unsubstituted coumarin. Sulfonation is operated upon the coumarin by treating with this fuming sulfuric acid. Fuming is not required, sorry. Sulfuric acid to be operated, which able to generate that neutral sulfur trioxide electrolyte will be originated, giving rise to 6 sulfonic acid. 3,6 disulfonic acid is also the kind of a consequence of the sulfonation process. So mixture of products will be originated instead of monosubstitution. And let me perform the nitration over this coumarin. Whenever nitration is carried over the coumarin molecule, that nitro will be substituted at the position number 7. If same coumarin to be operated with dimethyl sulfate in the presence of strong base sodium hydroxide, so that immediately ring opening is reaction carried, that able to generate. So here dimethyl sulfate DMS will be operated over there, so that oxygen will be alkylated. It is converted into wherever this lactone oxygen is there, that pyran ring oxygen will be methylated, giving rise to methoxy. And another wherever ketonic functionality is there, again that ketonic functionality is also reacted with this dimethyl sulfate, giving rise to OCH3. So this is the way 2-dimethoxy will be originated at the terminal sites. Here is the ester linkage, here is the ether linkage, is the consequence of this dimethyl sulfate and sodium hydride. Anyway, nitration giving rise to nitration at the position number 3, 4, 5, 6. Position number 6, 6-nitro coumarin as the final product. Hydrolysis is also possible. Just now we gone through this one. Whenever sodium hydroxide is operated over, sodium hydroxide is able to cleave this ester linkage, giving rise to ONA and COONA. Upon the reaction with concentrated hydrochloric acid, again restoring that coumarin nucleus is possible. This is the reason why here ring opening and closure are possible by reacting with base and acid respectively. Fluorescent nature, right? Coumarin is also having fluorescent property, that is the fluorescent compound can be synthesized by condensing that polyannular system, which is much larger in nature. And here is the coumarin NN diethyl amine is located over the position number 4, 5, 6, 7. Position number 7 in diethyl amine is there. And at the position number 3, we are having acyl chloride, and this is the way the coumarin compound to be treated over this polyannular system. Under the conditions like basic triethylamine base is applied over and giving dissolving in the solvent of dichloromethane. Dichloromethane is dissolved, is supposed to be dissolved in that, and here the nitrogen whichever present in this heterocyclic ring system, this hydrogen and this chloro to be condensed. So that the condensation by removing hydrochloric acid, so extension of the chain is possible, that is fluorescent in nature. The compound generated is more fluorescent in nature. UV light emission is possible. Fluorescent nature of the compound is proven by this kind of light emission property. Polymerization is also the characteristic for this coumarin. Whenever we are taking 4-hydroxycoumarin as the starting material to be treated with this polymeric substance, this the dibromo alkane to be taken, and potassium carbonate is the catalyst to initiate this reaction, giving rise to kind of alkylation over the position number 3. So position number 3 is supposed to be alkylated, and moreover the kind of monomer generated to be binded with another molecule of coumarin and giving rise to polymeric substance of that coumarin. This is the way polymeric substance will be generated. Polymerization is also the characteristic for this coumarin, having multiple applications. Let me perform this acylation of the coumarin. Coumarin is supposed to be reacted with glacial acetic acid and phosphorus oxychloride. Whenever glacial acetic acid and phosphorus oxychloride to be treated, giving rise to this 3-acetyl coumarin. 3-acetyl coumarin will be generated. This generated 3-acetyl coumarin can be treated with acetophenone. This is said to be acetophenone, and the conditions applied will be strong base piperidine and chloroform at the temperature 80 degrees centigrade, so that able to give the condensation in between. Whenever condensation is accomplished, this able to condense with this adjacent chain. There is a alpha beta unsaturated carbonyl compound will be originated. So the acetophenone will go for this condensation over this carbonyl carbonatum, giving rise to extended chain. So this is the extended conjugated chain will be a product. So that this is the reaction said to be 3-acetyl coumarin, said to be acylation reaction only. Now, ring opening, how it will participate in the ring opening reaction? The initial coumarin, where we are having olefinic double bond supposed to be epoxidized. So epoxide formation, obviously you can add that hydrogen peroxide or metachloroperbenzoic acid, so that that olefinic double bond will be epoxidized. So you can achieve 3,4 coumarin epoxide as the intermediate product. Immediately that epoxide, whichever highly strained one, so that immediately it will go for the ring opening reaction, giving rise to open chain molecule in this manner. This is the way ring opening reaction is also accomplished upon the coumarin. Welsmeyer-Huck formulation is the characteristic named reaction which is performed by this coumarin. Coumarin is supposed to be treated with dimethyl formamide and phosphorus oxychloride. So that coumarin characteristic formulation is accomplished at the position number 3. So that coumarin 3-carbaldehyde will be the expected product. This further go for the reactivity. Coumarin 3-carbaldehyde can be treated with the sodium azide and this kind of acetonitrile together, so that a kind of triazole will be originated, not a triazole. It is the kind of six-member ring system originated over this position. This position, third and fourth carbon atoms, whichever present, both are able to build up a six-membered ring system with the two nitrogen heteroatoms. Latter being azide is also taking part of this one, so that a triazole molecule is also developed over this coumarin nucleus. So it is said to be, whatever molecule generated is said to be chalcone. Chalcone is a highly reactive molecule. It is the drug active motif. Chalcones are said to be drug active motifs. So that this kind of new auxiliary will be generated by means of this Wells-Mayer-Hack formulation will have a potential drug applications in the curative agents. Synthesis of coumarin chalcone derivatives. Chalcones are derived starting from this coumarin. I'm taking 3-acetyl coumarin as the starting material to be treated with again kind of methyl benzoate. This is said to be methyl benzoate, and ethanol is taken as a solvent. Piperidine is the kind of a basic catalyst to be applied whenever this 3-acetyl coumarin to be treated with this methyl benzoate, that able to go for the condensation reaction. Condensation is accomplished between this carbon of this coumarin ring, this coumarin acetyl to be operated, and this will be removed from the system and able to form alpha beta unsaturated ketone once again, which is again designated as a chalcone moiety. Chalcone will be originated. Then how can we transform the compound whichever taken into a kind of coumarin which is in conjunction, which is in combination with the thiazole? Coumarin thiazole hybrid scaffold synthesis, which is more potential in the field of pharmacology, because by extending the conjugation, by extending the number of heterocyclic ring system, their activity will be amplified, the many folds, amplified by many folds. This is the reason why 3-acetyl coumarin to be reacted with the benzaldehyde in the presence of this is called water, thiourea. Thiourea is another substituent, another reagent to be added, and ammonium acetate is another material to be added over, that able to giving rise to coumarin, which is connected with this thiazole molecule, and here is the kind of imine linkage with another benzene is also present. This is the way synthesis of thiazolyl coumarin is carried. The requirement will be 3-acetyl coumarin to be treated with this benzaldehyde and thiourea, so that here coumarin thiazole hybrid scaffolds will be synthesized on the laboratory platform. Coumarin-imidazole. So we are trying to incorporate various heterocyclics together, so that whenever coumarin 2 methyl chloride is supposed to be reacted with imidazole. Imidazole is having this thioalcohol functionality over the position number 2. Imidazole thioalcohol is the reactant to be operated. Hydrogen from this SH and chloro from this CH2Cl. Hydrochloric acid will be removed by condensation process, so that simple linkage, thioether linkage will be originated between imidazole and the coumarin together, giving rise to coumarin-imidazole hybrid scaffolds. These are having amplified activity in comparison to the individual coumarin, individual imidazole as well. That's the reason why we are combining the multiple heterocyclics on the same platform, so that skeleton with the amplified activity can be originated. By this various chemical reactivity, chemical applications of this coumarin got discussed in detail, and now we entered into the important segment of the session called application purview regarding this coumarin. In what ways coumarin is applicable? Coumarin is an efficient anticoagulant agent. Marketed drug is available, the coagulating agent, and that is said to be warfarin. Warfarin is having dual activity. In terms of coagulation stands for wherever blood secretion is there, that will be blocked. That secretion, blood circulation will be blocked. That is called a coagulation. Whenever blood circulation blocks, what happens? pumping of blood may not be possible to entire organisms, entire organs of the system, so that oxygenation of that organs may not be continuously possible, so that entire body may become anemic, right? And functioning of heart also becomes very complicated. Cardiovascular disease is also the consequence of that coagulation process. So that anticoagulant is the efficient which used to avoid the clots, which used to dissolve the clots, so that blood pumping will become very convenient, and giving rise to proper functioning of the blood pumping, proper functioning of the heart, systolic and diastolic sessions, right? That is the way warfarin is working. In the another phase of the coin, it also works like a mouse killer. So rodenticide, warfarin is the well proven rodenticide, which is composed by this coumarin, which is in contact with the hydroxyl over the position number 4. At the third position, we are having bulky alkyl side chain, which is said to be warfarin, composed by C19H15 NaO4, and this is the most important proven drug with respect to anticoagulant and rodenticide as well. Anti-inflammatory. So many drug molecules are mentioned over, which is having a reduction of inflammations. Wherever we are experiencing severe pain because of the muscle contraction, because of muscle rupture, because of the muscle injury, because of the surgeries, whatever it kind of might be. So that inflammations are the causes for these many symptoms, right? So whenever inflammations are caused over, they can be effectively curated by means of Coumarin related drugs, whichever manifested over here. Here is the Coumarin, which is in conjunction with this ether linkage, and the terminal amine is also located. And here we have this amino functionality over the position 3 bounded with this aldehyde, benzaldehyde molecule. This is also anti-inflammatory. And another alkyl side chain is there over the position number 4. And here we are having this imine linkage over the position number 3, 4, 5, 6, 7. Seventh position is having a imine linkage. And here we are having amide linkage over the position number 3 and hydroxyl over the position number 4. All together are proven for the anti-inflammatory activity, and they are efficient curative in order to remove the pains, relieve the pains because of this muscular contractions, etc., right? So these are proven antibiotics which are originated from this coumarin skeleton, novobiocin and chlorobiocin. You can locate both are said to be Coumarin derivatives only, and they are extended with the multiple side chains as well. Here, chloro is the extra ingredient incorporated onto the coumarin ring in order to intensify its activity, and both are effective antimicrobial, able to kill the pathogens whichever causing diseases included with bacteria, virus, fungi, protozoas, and algae, and kind of worms. So many tiny microorganisms whichever inducing the diseases by disturbing the immune system, those can be effectively curated by the drugs called novabiocin and chlorobiocin together. Antiviral agents also, this kind of activity is also proven for these coumarin molecules effectively. These many drugs whichever manifested in this slide are working again is the influenza. Influenza is the kind of cold symptoms you can notice, running nose and headache conditions, and soaring throat. Soaring throat are the symptoms related with this influenza viral disease, which is causing viral infection, especially to the nose, throat, and headache is also the kind of symptom which is mentioned over there, and feverish conditions also influenced by means of this influenza. And the drugs whichever manifested here, that is angelicin and soralin. And here we are having the kind of drug which is having coumarin skeleton over there, working again is this influenza virus. Anti-cancer agent, multiple anti-cancer coumarins are already proven and they are in the market to cure the effective dready disease, very chronic cancer disease, which is the most chronic disease in the worldwide. And here is the coumarin related motif, which is in conjunction with this quinoline. And here you can notice this imidazole molecule as well. So this together is having the effective anti-cancer curative property. So whatever drugs manifested in this are the scaffolds which are manufactured by coumarin and quinoline together. Here again, coumarin quinoline together, structure activity relationship is promising in order to intensify this anti-cancer curation by means of these two kind of heterocyclic compounds together. And a neuroprotective agent, it will be another pharmacological impact of this coumarin will be neuroprotective agent. It will be especially in the curation of Alzheimer's and Parkinson's. Alzheimer's is caused by that kind of brain activity will be disturbed, so that they are not able to remember the things for longer time. That is said to be what Alzheimer's, and Parkinson's due to the deficiency of the dopamine neurotransmitter, giving rise to a kind of the neurological disorderness will be induced into the patient, so that neurological disorders both will be effectively curated by this neuroprotective agent called coumarin. The scaffolds whichever manifested here are effective neurotransmitting agents, effective neuroprotective agents working against this Alzheimer's and Parkinson's together. And anti-malarial as well. Here is the drug whichever manifested. Here is the coumarin nucleus and amide linkage is there, and here is the alpha beta and saturation located, and here is the benzene ring. This kind of extended chain over the position number 3 is able to cure this disease called malaria, which is the insect disease, so mosquito induced disease it will be. So which is the coumarin 3-aryl cinnamomide drug, which is the effective curative against this disease called malaria. And material chemistry applications are more proven for this kind of coumarin in the field of fluorescent activity. Being the compounds are exhibiting their light themselves, they that is said to be chemiluminescence, and they are exhibiting UV ultraviolet radiation, so that they are bright in nature. That is said to be what a fluorescence. They are exhibiting fluorescent nature, right? This is the way the compound whichever manufactured here, where you can locate the coumarin nucleus. Here also coumarin nucleus. These are proven for the efficient fluorescent activity due to the emission of ultraviolet radiation that is manifested over here. Coumarin biosensors are also available. Biosensors are meant for in order to check your heartbeat, in order to check your pulse rate, in order to check your blood pressure conditions, in order to check your nutrition levels, in order to check the conditions inside the living organisms. Those are said to be biosensors. Biosensors are working without any physical test. Need not to take the blood always, a blood test, and a kind of external test may not be required. Rather, they are equipped. The sensors are whenever they are directly in contact with the skin, they are able to monitor the internal system and giving the response, so that coumarin based biosensors are available. The compound whichever manifested over here, that is a coumarin, and having the alkyl side chain over the position number 3 and the thioether functionality over the position number 4, and here the tertiary amine over the position number 7. So this together is having the activity of biosensing, and that is proven. So it is also kind of material science application. And promising application for this coumarin will be the polymerization. Polymers may have further extendable applications in the field of material science, so that here coumarin is supposed to be treated with this kind of 2-vinyl acetyl chloride to be treated in the presence of triethylamine, and methyl formamide to be operated, giving rise to polymeric substance in between this ether linkage and this chloro, both to be reacted and giving rise to extended chain between this coumarin and this kind of acid chloride. So that to be propagated in such a manner, giving rise to lengthy chain of the polymer finally, which may find a profound applications in the field of material chemistry. Anti-Alzheimer's, just now we gone through the compound, neuroprotective agent it will be, and some other molecules also mentioned, which is having polymeric functionality over there. And this is the coumarin nucleus, which is the active pharmacophore and having a benzene nucleus over the position number 3. And here is the ether linkage and the alkyl, lengthier alkyl chain is located in between. And here is the pyridinium bromide. Pyridinium bromide is also the part of this one. Because of this combination of this pyridine and coumarin together, the amplified activity again is this Alzheimer's disease is possible. Defective brain functioning can be effectively regulated by means of this drug. Coumarin in perfumes, being it is the aroma and the sweet smell exhibiting molecule, so that it is obvious to use coumarin in perfume, so that so many compounds can effectively use in the perfumery industry. Cosmetics as well, right? Vanilla flavor is also provided by this coumarin. That's the reason why it is the flavoring agent in a food material, being it is a spice. Coumarin is the spice, so that we can use to amplify the taste of that food, so that it is the food flavoring agent. And vanilla flavor is the obvious condition for this coumarin, so that vanilla flavor is also that is traded, marketed kind of compound it will be, which is composed by the coumarin. Coumarin as the pesticide. So many established pesticides which composed by the coumarin are established already. And here you can notice the compounds with the coumarin ring over the position number 6, lengthy alkyl chain, and here is the ester linkage over the position 7. And another polymeric substance is also located. All together are proven for the pesticidal activity, which used to kill the pests which causing the diseases over the croplands, to reduce the crop yield, so that this being it is a natural material, so that coumarin based compounds effectively working upon the pests which are destroying the crop yield, so which able to secure that croplands. Right, coumarin-based pesticides again. These many pesticides can be synthesized. CMCS is the kind of compound taken that can be treated with this coumarin-based compound. This is a coumarin-based compound we are having. Both are reacted together, giving rise to a polymeric chain. A very lengthy polymeric chain is generated. This is a 6-member ring system with the furanose, and this is the kind of coumarin nucleus which are combining together. Simulated sunlight, both are working upon the sunlight, both are working upon the pest which are working against the pest, giving rise to pesticidal activity over the croplands, and effective securing the crop health is possible by destroying the pest by means of this natural pesticide. By this, we successfully accomplished the entire session pertaining with the coumarin and what could be the origin and where you can locate this coumarin and what kind of synthetic strategies are manifested for this coumarin. How many scientists kept their efforts in order to synthesize this effective scaffold, and what could be the physical properties, how it exists, and what is the solubility, and if it is added with any kind of reagent, what kind of chemical transformations occurred within the compound. That detailed study is provided. In specific, multiple applications pertaining with the coumarin are detailed description provided within the session, and I hope this is more informative for all the viewers, and especially towards the aspirants for that kind of coumarin-based research who are working in the laboratory field, in the research, in the pharmaceutical manufacturing, bulk drug, and also research methodology. And those who are scholars in this domain, that the kind of session is most informative. Those who are aspirants of the competitive exams and entrance examinations as well in the field of chemistry, the session will be very much helpful. And the session conducted by Dr. Kavita Kottireddy Kota. I hope the session you enjoyed very well, and we will come up with more such kind of quality content in the near future. Thank you very much.